Last episode, Catalyst built a plan. It looked at statistics about your tables, estimated the cost of several strategies, picked the cheapest, and compiled that into code before your job started. Here is the problem with that. At planning time, Spark does not know what your data actually looks like. It knows what it looked like last time somebody ran statistics. And data changes. Partitions that were once balanced become skewed. Filters that were once selective stop being selective. The plan Spark committed to before your job ran is based on a description of your data, not the data itself. A plan being committed at planning time on the left, with the actual data looking very different on the right, labeled planned on old statistics. So here's the situation Spark found itself in. Every shuffle produces a side effect. Once every machine has written its map side output and the reduced side has fetched its slices, you have real counts, real sizes, real skew distributions. The truth about your data exists right there at the end of every stage. Before adaptive execution, Spark threw that information away and continued with the original plan regardless. A shuffle completing with real statistics appearing beside it and an arrow showing them being ignored, labeled real truth discarded. Adaptive query execution, which we will call AQE, changes one thing. It has been on by default since Spark 3.0 and can be enabled with a single config flag on older versions. After each shuffle completes, Spark looks at those real statistics and asks, given what I now know, would I plan the rest of this job differently? If yes, it replans. On the fly, mid-job. A shuffle completing, real statistics appearing, Spark examining them and redrawing the remainder of the plan, labeled replan with real data. 3 things AQE can do with that information. We will take them in order of how often they save you. The first is partition coalescing, and it solves a problem so common it is almost universal. Our fraud job filters aggressively. We start with 3,200 partitions, and after the filter, most of them are tiny or empty. Data that once filled 128 megabytes per partition now fills a few kilobytes, but there are still 3,200 of them. 3,200 partitions shown before a filter, and after the filter, the same count with most shown nearly empty, labeled 3,200 tasks for almost nothing. Each one of those empty partitions is still a task.
A task that gets scheduled, dispatched to an executor, run, and reported back. With 3,200 nearly empty partitions, your cluster spends more time managing overhead than doing work, and overhead does not scale. Adding more executors makes it worse, not better, because now you are managing even more tasks that take 1 millisecond each. Once the shuffle after the filter completes, AQE can see exactly how much data landed in each output partition. It combines small adjacent partitions into larger ones before the next stage starts. Adjacent is the keyword. Non-adjacent partitions cannot be merged without a new shuffle to bring them together, which would cost more than the problem it fixes. 3,200 tiny partitions might collapse to 12. Your next stage runs 12 tasks on real data instead of 3,200 tasks on almost nothing. 3,200 small partition bars collapsing into 12 larger ones after the shuffle, labeled 12 tasks instead of 3,200. The second thing AQE can do is flip a join strategy mid-job, and this one can be the difference between a job that takes an hour and one that takes a minute. We are joining our swipes to our merchant table. At planning time, Spark estimated the merchant table was too large to broadcast, so it chose a sort merge join. Sort merge joins shuffle both sides. The swipe side is 400 gigabytes. That is a very expensive shuffle. But our job filters merchants before the join. We are only keeping active merchants with more than 100 transactions in the last 90 days. Spark estimated how many that would be, but it was wrong. The filter turned out to be far more aggressive than expected. The filtered merchant table is not 2 gigabytes, it is 200 megabytes. A merchant table estimated at large on the left and measured at small on the right after filtering, with a join strategy label flipping from sort merge to broadcast. 200 megabytes can be broadcast to every executor. Once the stage that filtered merchants completes, AQE sees the real size, and if it falls below the broadcast threshold and the join type supports a broadcast, it flips the strategy. The 400 gigabyte swipes table never moves. Only the small merchant table does, once, to every machine. The savings here are not marginal. You went from shuffling 400 gigabytes to not shuffling it at all. Two paths. The top reading sort merge, shuffle 400 gigabytes, and the bottom reading broadcast, send 200 megabytes once, with matching stopwatches showing the cost difference. The third thing AQE can do is handle skew, and we'll go much deeper on skew in episode 7, but the short version is this. Sometimes one key ends up far larger than all the others, because one key appears far more often than the hash function expected. 500 tasks run in 2 minutes. One runs for an hour. AQE can split that oversized partition into smaller pieces and process them in parallel. It cannot split them perfectly, and it does not catch every kind of skew, which is why skew gets its own episode. But it handles the most common case automatically without you having to know it happened. Now pause the video and ask the obvious question. If AQE is replanning mid-job, what does the plan you read in episode 4 actually tell you? It tells you the initial plan, the one Catalyst built before the data was touched. AQE changes what actually runs, and that change will not show up in the explain output you printed before the job started. To see what AQE did, you look at the Spark UI after the job completes, where the adaptive plan is shown, and you will sometimes find that the join strategy in the UI is different from the one in the explain output. This is not a problem, it is the system working, but it is worth knowing because it is a common source of confusion when the explain output and the UI seem to disagree. One last honest note. AQE is not a substitute for understanding your data. Partition coalescing cannot run if you never shuffle because it has no statistics to work with. The join flip only happens if the real size falls below the broadcast threshold, and that threshold has a limit. Skew splitting helps with the most common pattern, but misses exotic ones. AQE catches things that were genuinely hard to avoid. Stale statistics, a filter more aggressive than anyone expected, a key that became hot after the plan was made. It does not catch the shuffle you should not have written at all, and it did not catch the old repartition call from episode 4. So here's the big picture. Catalyst plans from statistics that may be stale. AQE waits for the real statistics that appear at the end of every shuffle and uses them to replan the rest of the job. It can coalesce small partitions after a filter, flip a join strategy when the real size turns out smaller than expected, and split a skewed partition. But the plan you read in the explain output is still the initial plan. AQE changes what runs, not what was predicted. Next time, that join strategy choice in full. Broadcast hash, sort merge, shuffle hash. The same join, 40 times faster. Nothing changed, but which one ran.